Okay, so good morning, everyone. We're gonna finish off this lesson on solving for the unknown for lesson 3. Basically, we're on page 15. We are going to use the trig ratios. Okay, just to kind of refresh our memory, the three trig ratios that we're using are sine, cosine, and tangent ratios. And so usually the questions that I get asked is, when do I use a trig ratio? When do I use the sine, cosine, and tangent ratio? And I usually say if there are sides and angles involved in questions. Okay, so that's a kind of like a hint on when to use a trig ratio. Okay, so if there are sines and angles kind of involved in the situation, in the question. So I'm just gonna write down the trig ratio in here so that we have it in front of us. Okay, so the first one is sine theta is equals to opposite over hypotenuse. The other one is cosine theta equals to adjacent over hypotenuse. And then tan theta equals to opposite over adjacent. These are the ones that we're using. Now, before we dive in there, let's take a look at our calculator first. We're gonna see if we could do some calculator stuff first, okay? We're going to do a little bit of an activity on our calculator. So on your calculator, yesterday we were able to locate the sine, cosine, and tangent, right? Now, what we're going to do is we're going to take a look at the inverse. Okay, so let's give it a try here. Let's give it a try. Using our calculator, can you take the cos inverse of 0.5? Cos inverse of 0.5. So how would you do that on your calculator? Okay, can you see the cos inverse, the -1? Are you going? Are you going or?
No.
So cos -1
Yeah.
equals?
So you're gonna see in my calculator, okay, you see the cos inverse up here, right? So to activate that, we need to go second function. So most of our calculator, it would be a second function, okay? Cos inverse of, and then you type in 0.5 and then press equals. Okay, did everybody get 60? Did everybody get 60? Now, some calculators, I know 2 of our students here have a calculator that's slightly backwards. Okay, so I'm gonna
So you press your shift first, and then your close, because that minus one is on top of it. But you gotta press shift first, then your close or your reverse.
Okay, everyone's good?
This key I have to press.
Good? Oh, okay. Yeah, maybe I'll help you out in a few minutes. I'll like to go through that example. Okay, so that's good. Now everybody got a 60.
Yeah.
And that's actually 60 degrees. Okay, let's try one more time, okay? Let's try one more time. What's tan inverse of 1.7? Tan inverse of 1.7. So let's try that again.
59.53.
Okay. You got 15, did you get 59.53? Yeah?
59.53.
Yeah. So it's 59.53.
Remember to press your shift.
Yeah.
Bar.
We're gonna see, you're gonna activate the cos inverse and tan inverse. Okay, let's do one more time. One more, okay? What's a sine inverse? Sine inverse, okay? Remember there's an inverse there at the top. Sine inverse of 0.9. Sine inverse of 0.9. $64.16. Okay. Okay, now that we've practiced that, we're gonna use that for our.
So you said all of these are in degrees?
Yeah, yeah. And then you'll see it why. No, that this is not a temperature. This is just degrees, the angle. Yeah, yeah. Okay, now we're gonna see what that is about. Okay, in this particular case, we're actually gonna solve for the angle. Solving for the angle. This angle here, what is this angle theta? What do you call this side? The 26. The opposite side. What do you call the 41? Hypotenuse. Because it's right across the 90-degree angle. So this is the hypotenuse. So we're gonna take a look. Okay, which one am I gonna use? Which one has the opposite hypotenuse and theta in my question, in my formula? Are we going to use sine? Are we going to use cosine? Or are we going to use the tangent? We're going to use the sine, right? Because the sine has the O, opposite, and hypotenuse. Opposite and hypotenuse. So sine theta equals opposite over hypotenuse. Okay, so we first labeled the triangle. We've now figured out which formula to use. In this case, it's sine. And then the next step is for us to substitute the values in. So sine theta, okay, because we don't know what theta is, equals to opposite. Okay, what's my opposite side? I'm gonna replace it with 26 divided by hypotenuse. How big is the hypotenuse? 41. Okay, good. So far so good? Okay, now here's the thing. What we're gonna do is we're gonna solve for theta. So let's go. First of all, let's do this. We can figure this out, right? What's 26 divided by 41? What's 26 divided by 41? Okay. 0.63. Okay. Leave that information on your screen. Okay.
6.364.
Okay. So just take a look at what I'm gonna do for now. What we're trying to do is we're solving for theta, meaning we need to have it alone. Okay. So let's focus on this one for now. And then I don't want you to miss something important. We want to have the theta alone. How do we get the theta alone? Well, somehow we have to get rid of sine. We have to get rid of sine. Now, what's the opposite of sine? Well, that's the sine inverse. The sine and the sine inverse are opposite operation of each other. They're inverse operation of each other. Just like adding, the opposite operation of adding is what? Subtracting. Just like multiplying, what's the opposite operation of multiplying? Dividing. The sine operation, the sine function, not an operation, the sine function has an opposite as well, or inverse. That would be the sine inverse. So if I take the sine inverse, they cancel each other out. Okay. Now if I take the sine inverse on this side, I also will have to take the sine inverse on the other side to maintain the balance. So sine inverse on that side, and I need to take the sine inverse on this side. So that makes the sine inverse and sine cancel each other out. Okay, so that's when they cancel each other out and we have theta left. So here we're gonna we just figure out 26 over 41, right? So now from here, don't erase anything off. We're gonna take the sine inverse, second function, sine inverse of that answer. And then I think everybody has an answer button. So press answer button. Sine inverse of the answer, and then press equals. It's gonna say it's approximately 39.36 degrees. Okay. So the angle there is 39.36 degrees. Okay. Did everybody get 39.36 degrees? Okay. We're going to go through example number 2. Okay. I mean, this is fairly new to us. We're going to take it, take more examples so that we're a little bit more comfortable. Okay. In this particular case, okay, this is what I'm thinking about. In this particular case, in my question here, it has angles and sides involved. Angles and sides involved. Okay, in the question, it has theta, and then you got the two sides. So that means I'm going to use one of the trig ratios. One of the trig ratios. So, but which one is it? Okay, so this is our theta. Now we're going to label these two sides. So what do you call the 19? What do you call this one? This is called the adjacent. Adjacent. What do we call the 26?
Opposite.
Opposite, right? Because opposite means right across from the given angle, and then adjacent means right beside the given angle. Okay, so this is the opposite is 26. Now let's take a look at the trig ratio. Which of the three trig ratio do you think we're going to use? Sine, cosine or tangent? Tangent. Tangent, right? Because the tangent has opposite and adjacent in that formula. So let's write down the formula. So tangent theta equals to opposite over adjacent. Okay, so what do? We looked at this and said, okay, in this triangle, I have angles and sides involved, so it has to be one of the trig ratio. And then we labeled them out, and then the labels will help us figure out which formula to use. Now that we have a formula to use, let's go and substitute the values in. So tan theta equals to opposite. Okay, what's my opposite side? It's going to be 26 divided by adjacent. What's my adjacent? 19. Okay. Now, we're going to have the theta alone, and we have to get rid of the tan. So what are we going to do? We're going to take the tan inverse in this case, right? So we will take the tan inverse in this case. So theta equals to, okay, let's figure this out first. 26 divided by 19. So 26 divided by 19 equals, we got 1.364. Okay, I'm going to give a little bit of maybe a few seconds to get everybody at this particular point. Okay, 26 over 19. Okay, and now because this is the tangent, we're going to do the tan inverse. Tan inverse.
36.
No, 26. What did you type in?
56.
And then so you're going to go second function, tan, for tan inverse of, answer, and then enter. It would be 53.84 degrees. 53.84 degrees. Is it getting better? Is it getting, Okay. It gets easier. Any questions about this piece? You okay? Okay, let's go take a look at example number 3, last but not the least. Okay. So I look at this and I have angles and sides involved. I got angles and sides involved. Okay, the theta. So I know I have to use one of the trig ratio. Let's label them up. So this is my theta, this is my 90-degree angle. What do you call the 21? What do you call the side that's 21? It's H, right? It's called the hypotenuse. Hypotenuse. Very good. You guys have been studying. What do you call the side that is 13? Adjacent. Yeah, very good. Adjacent. Okay. And then this is our theta. So which trig ratio are we going to use? Cos? Yeah. So because we got sine, cos, tan. We have adjacent and hypotenuse, so it's going to be cos. Cos. So let's write down the formula. Cos theta equals to adjacent over hypotenuse. Now we substitute the values in. So cos theta adjacent, I'm going to replace with 13 divided by hypotenuse. I'm going to replace with 21. Now you see here we're taking cos This is cos. So do the opposite, it would be the cos inverse. So theta. Okay, so we're gonna take cos inverse. So 13. Let's figure this out first. 13 divided by 21. It's gonna give us a whole lot of numbers, right? 0.619. Keep all the decimals, and then we're gonna take the cos inverse of that number. Cos inverse of that answer that we just got. And I got, if somebody verify my answer, I got 51.75. Did you get 51.75? Yeah. Degrees. So that's this one here. This angle is 51.75 degrees. So I'm gonna write that down in here too. So we take the cos inverse here because of this is cos. And then example number 2, we take the tan inverse. Okay. Now it's just just like the new stuff, new things, new skill that you're learning, it takes practice to get awesome. Okay, it takes practice to be really, really good at it. So
This is reducing is subtracting, right?
no, cos inverse, cos inverse, yeah. No subtracting here. Yeah. Okay. So leave that with you. So you have some practice questions for you to do. Okay, some practice questions. And there are assignment questions. Assignment number 3. Do the practice first and then do the assignment number 3. Yeah. I think what we'll do is we'll just do the practice one first. Okay? So if you are still working on practice questions on page 14, you can work on that one. And practice on page 16, you can work on those ones for now. Okay? There you go. And then we'll be around to kind of answer some questions. I got your question.